let's do an additional example set for derivatives of log functions just to give you some more examples. All right, so I have the natural log of 4x over x plus 1. So to do that, what I'm going to do is I'm going to use the log rules that allow me to split this up. So that tells me that this function is natural log of 4x minus natural log of x plus 1. So then when I take the derivative, the natural log of some constant times x is 1 over x. And the natural log of x plus 1 is minus 1 over x plus 1 times the derivative of x plus 1, which is just 1. So that's all you have to do to find that derivative, breaking it up. So it's kind of nice because you don't have to use like quotient rule, you don't have to use any of that. You can use these log rules, split these things up. It makes your life a lot easier. Now for this thing, you're not going to get it, it's not going to be as easy. So what we have to do for g prime here is we have to say, okay, 1 over x plus the square root of 5 plus x squared times this thing's derivative. So in this case, it's just going to be, it's going to be kind of ugly. So the derivative of x, luckily, is just 1. But the derivative of this, so since that's a square root, it's like a 1/2 power. So it's 1/2 5 plus x squared to the negative 1/2 times the derivative of the inside by the chain rule is 2x. So then if those 2's will cancel, this will become a square root in the denominator. So that gets me 1 plus x plus square root of 5 plus x squared times 1. Sorry, that's not a times there. That should be a plus. Sorry, that's a plus. 1 plus x over the square root 5 plus x squared. So there's a way to simplify this. I'm going to do that over here in just a minute, but this is an answer. So for this one, what you're going to do is, okay, you have a natural log of the absolute value. Okay, well I've done that. I know that the absolute value version is the same as if I didn't have it, so I'm in good shape. So what I'm going to do though is I don't like secant. Who wants to deal with secants, right? So what I know is that secant is 1 over cosine. So then I can split that up. I can say, well, that's natural log of 1 minus natural log of cosine 3x. But we know natural log of 1 is just 0. All right, we know that's 0. So what we're really doing is we're taking the derivative of the negative natural log of cosine 3x. So h prime of x is negative 1 over cosine 3x, right? We carry the negative. It's 1 over this times the derivative of cosine 3x, which is negative sine of 3x times the derivative of 3x, right, by the chain rule. It's 3. So those negatives cancel, so I end up with 3 sine of 3x or cosine of 3x, which is 3 tangent of x. Pretty clean. Now for this one, let's be a little clever with ourselves, and let's get a common denominator here. So you're going to have all right, we have this piece. Now for this piece, the common denominator is the square root of 5 plus x squared. So now we have the square root of 5 plus x squared plus x over the square root of 5 plus x squared, right? Well, lo and behold, those two are the same, right? That we have the same top and bottom there, so our final answer is 1 over square root of 5. Which is actually kind of neat. That's kind of clean. But it might have been harder to arrive at if you didn't think to get the common denominator.